Imagine a place in the universe where time stops, light disappears, and the laws of physics collapse. A place where everything that enters never returns. Welcome to the edge of reality, the black hole. But what exactly is a black hole? And what would happen if you fell into one? Let's start from the beginning. A black hole is not a hole. It's an incredibly dense object, so compact that its gravity pulls in everything, even light. It's created when a massive star collapses under its own gravity. The star explodes in a supernova, and what's left is a point so small, so heavy, we call it a singularity. Around this singularity is the event horizon, the point of no return. Once you cross it, you're trapped forever. Not even light can escape. Now, imagine a person falling into one. At first, it wouldn't notice much, drifting in space, slowly getting closer. But the closer they get, the stronger the gravitational pull becomes. Feet first, the gravity difference between their head and toes stretches them. We call this terrifying process spaghettification. Yes, you heard right. You be stretched like spaghetti, and then you vanish from the outside world. Anyone watching would never see you actually fall in. You'd appear frozen at the edge, slowly fading into darkness. But for you, time would feel normal until the very last moment. And light? When it falls in, it doesn't reflect, bounce, or come back. It simply disappears, which is why a black hole looks completely black. It's not emitting any light. But wait, does it really disappear forever? Or does it go somewhere else? We'll dive into that in the next episode. So what's inside a black hole? We already know what happens on the outside. The warping of space, the freezing of time. But inside, that's where things get really strange. Once you cross the event horizon, physics as we know it breaks. Gravity becomes infinite. Time and space start to twist into each other. You're not just falling through space, you're falling through the fabric of reality. Einstein's theory of general relativity tells us the center of a black hole is a singularity, a point with zero volume and infinite density. But here's the catch. Infinity is just a sign that we don't understand what's really going on. Some scientists believe that the laws of physics don't end at the event horizon. They just change. Could the inside of a black hole be something else entirely? A portal? A bridge to another universe? This is where the idea of the Einstein-Rosen bridge comes in. You might know it by a more popular name, the wormhole. It's a theoretical shortcut through space-time, and black holes might be one end of it. So, if you fell in, maybe you wouldn't be destroyed. Maybe you'd be transported somewhere new, somewhere unimaginable. But here's the problem. We can't observe inside a black hole. No signal, no light, no data comes back. It's like trying to understand the inside of a locked box without ever being able to open it. Still, new theories suggest that black holes may not destroy information, but instead encode it in a strange way. Maybe falling into one doesn't mean death. Maybe it means transformation. Here's the mystery that's been haunting physicists for decades. What happens to information when it falls into a black hole? Let's say you throw a book in. Not just any book, one that contains the story of your life. Every memory, every thought, every detail. The black hole swallows it whole. No light escapes. No signal comes out. But here's the problem. According to quantum physics, information can never be destroyed, ever. So where'd it go? This is the information paradox. Einstein's theory says everything that crosses the event horizon is gone forever. But quantum mechanics says, no way. That information must still exist. These two pillars of science, general relativity and quantum theory, are at war inside the black hole. Some scientists believed for a long time that black holes do destroy information, that the data is lost in the singularity. But others, like Stephen Hawking, propose something mind-blowing. What if black holes aren't permanent? What if they evaporate slowly? This led to the idea of Hawking radiation, a faint glow leaking from black holes over time. Eventually, they disappear. But here's the twist. If a black hole vanishes and takes all its secrets with it, what happened to the information inside? Did it vanish too? Or was it encoded somehow in the radiation? Like a cosmic whisper, leaving behind the final trace of everything it consumed? Modern physics still doesn't have a clear answer. But some theories say black holes don't delete information. They scramble it, stretch it, and smear it across their surface like a hologram. That's right. Some physicists believe the universe itself might be a hologram. Crazy? Maybe, but this mystery isn't over. Imagine standing at the edge of a black hole. From your point of view, time feels normal. Your heart beats, you breathe, you blink, but from outside, everything changes. To an observer watching you fall in, you slow down. Not just a little, but infinitely. You appear frozen, stuck just above the event horizon, forever. That's the first strange thing about time near a black hole. It bends. It stretches. It almost stops. This is called gravitational time dilation. The stronger the gravity, the slower time moves. And inside a black hole, gravity isn't just strong, it's off the charts. So what happens to your experience of time once you fall in? Strangely enough, from your perspective, time goes on. You wouldn't notice anything unusual at first. But here's the mind bender. The center of a black hole, the singularity, doesn't just lie ahead of you in space. It lies ahead in time. That means you're not falling toward it. You're falling into the future. There's no turning back, no slowing down, just an unstoppable pull toward a moment you can't escape. A moment where everything ends, or maybe everything begins again. Some theories even suggest time ends at the singularity. It's not just that you die. It's that the very concept of before and after ceases to exist. Think about that. No time, no space, just a point of infinite collapse. And yet, this is also where some believe new universes could be born. From one end, death. From the other, creation. Let's not sugarcoat it. If you fell into a black hole, you wouldn't survive. At least, not in the way we understand survival. The first thing you'd encounter is the event horizon, the point of no return. From the outside, it would look like you're frozen in time, slowly dimming, until you vanish completely. But from your own point of view, you fall and keep falling. Then the real nightmare begins. You'd experience what scientists call spaghettification. Yes, spaghettification. The gravity near a black hole is so extreme that it pulls harder on your feet than on your head. Much harder. Your body stretches, elongates like a noodle. First atoms, then subatomic particles get ripped apart. You're no longer you, just information falling toward the singularity. But here's the wild twist. Some scientists believe your information isn't lost. That somewhere, maybe even in another part of the universe, your story could live on. There are even theories that suggest every black hole could be a gateway to another universe, to another Big Bang, to another reality entirely. So maybe falling into a black hole isn't just an end. Maybe it's a beginning, a portal, a rebirth, a cosmic mystery we may never fully understand. And until we do, black holes remain the strangest, darkest, most mysterious objects in the universe, where science meets the unknown, where time, space, and reality break apart. And the greatest questions are still waiting on the other side.